Just over 4 light-years away from Earth lies our nearest stellar neighbour, a distant system known as Alpha Centauri. At first glance, that distance might not sound too extreme. In the vast scale of the universe, 4 light-years is practically next door. But in reality, it represents one of the greatest barriers humanity has ever faced. Because even though Alpha Centauri is the closest star system to us, it is still unimaginably far away. To understand why, we need to start with a simple question. What exactly is Alpha Centauri? Unlike our Sun, which exists alone, Alpha Centauri is actually a system of 3 stars bound together by gravity. The 2 brightest are Alpha Centauri A and Alpha Centauri B, orbiting each other in a slow cosmic dance. The third, much smaller and dimmer, is Proxima Centauri, the true closest star to Earth. Orbiting Proxima Centauri is a planet that has captured the imagination of scientists and dreamers alike, Proxima Centauri B. This world lies within the star's habitable zone, a region where temperatures could allow liquid water to exist. In theory, it could be one of the most promising places beyond our solar system where life might exist. So naturally, the question arises, if it's so close, why haven't we gone there? The answer lies in the concept of a light year. A light year is the distance that light travels in 1 year, about 9.46 trillion kilometers. Light moves at approximately 300,000 kilometers per second, the fastest speed possible in the universe. Even at that speed, it takes over 4 years to reach Alpha Centauri. Now consider this. The fastest spacecraft ever built by humans is Parker Solar Probe. At its peak speed, it can reach around 700,000 kilometers per hour. That might sound incredibly fast, and by human standards, it is. But compared to the speed of light, it's almost nothing. At that speed, it would take the Parker Solar Probe more than 6,000 years to reach Alpha Centauri. 6,000 years, longer than recorded human history. And that's just with our fastest current technology. So what if we built something faster? For decades, scientists and engineers have explored ways to push the boundaries of space travel. One of the most ambitious ideas is breakthrough starshot. This concept involves sending tiny, ultralight spacecraft, no larger than a computer chip, toward Alpha Centauri using powerful lasers. These lasers would accelerate the spacecraft to about 20% the speed of light. At that speed, the journey would take around 20 years. For the first time, interstellar travel would become possible within a human lifetime. But there's a catch. Actually, many catches. First, the technology required to build such a laser system doesn't yet exist at the necessary scale. We would need an enormous array of lasers working together with perfect precision. Second, the spacecraft would be incredibly fragile. Traveling at such extreme speeds, even a tiny particle of dust could destroy it instantly. Space, contrary to popular belief, is not completely empty. It contains microscopic debris, tiny grains moving at high velocities. At 20% the speed of light, even a speck of dust becomes a deadly projectile. Then there's the issue of communication. Even if the spacecraft survives the journey, sending data back to Earth across 4 light years would be incredibly difficult. Signals would take years to arrive and would be extremely weak. And that's just for tiny robotic probes. What about humans? Could we ever travel to Alpha Centauri ourselves? This is where the challenge becomes even more extreme. Human space travel is limited not just by speed, but by biology. A journey lasting thousands of years is obviously impossible for a single human lifetime. So scientists have proposed radical solutions. One idea is the concept of generation ships, massive spacecraft designed to carry entire communities of people. These ships would travel slowly, with multiple generations living and dying on board before reaching their destination. In this scenario, the people who arrive at Alpha Centauri would be descendants of those who first left Earth. But this raises serious questions. Could such a closed environment sustain life for centuries or even millennia? Would future generations remain committed to a mission they didn't choose? And what happens if something goes wrong halfway through the journey? Another concept is cryogenic sleep. placing astronauts in suspended animation for the duration of the trip. While this idea is common in science fiction, it remains far beyond our current capabilities. Preserving a human body for decades or centuries without damage is an unsolved challenge. Then there's perhaps the most extreme idea of all: faster-than-light travel. Theoretically, concepts like warp drives suggest it might be possible to bend space itself, allowing a spacecraft to travel vast distances without exceeding the speed of light. One famous example is the Alcubierre warp drive. Instead of moving through space, a warp drive would compress space in front of the spacecraft and expand it behind, effectively allowing it to move faster than light without breaking the laws of physics, at least in theory. In practice, this concept requires exotic forms of matter and enormous amounts of energy, far beyond anything humanity can currently produce. So for now, faster-than-light travel remains firmly in the realm of speculation. Even if we could solve the problem of speed, there are other dangers waiting in deep space. Radiation is one of the biggest threats. Outside the protective shield of Earth's magnetic field, astronauts are exposed to high levels of cosmic radiation. Over long periods, this can cause serious health problems, including cancer and damage to the nervous system. A journey to Alpha Centauri would expose travelers to this radiation for years, if not decades. Shielding against it would require thick layers of material, adding significant weight to any spacecraft, and weight is the enemy of speed. Then there's the psychological challenge. Humans are not designed to live in isolation for extended periods, especially in confined environments. Even missions lasting just a few months on the International Space Station have shown how difficult it can be to maintain mental well-being in space. Now imagine spending years, or generations, inside a spacecraft, cut off from Earth, with no possibility of return. The psychological strain could be immense. But let's assume, somehow, we overcome all these obstacles. We build a ship capable of reaching Alpha Centauri within a reasonable time frame. We protect the crew from radiation. We solve the problems of food, water, and mental health. We finally arrive. What would we find? The most likely destination is Proxima Centauri b, but this planet may not be as welcoming as we hope. Proxima Centauri is a red dwarf star known for intense stellar activity. It frequently releases powerful flares that could strip away a planet's atmosphere. This means Proxima Centauri b might be exposed to extreme radiation, making it potentially hostile to life. Additionally, the planet is likely tidally locked, meaning one side always faces the star, while the other remains in permanent darkness. One side could be scorching hot, while the other freezes in eternal night. Not exactly ideal conditions for human habitation. Even if life does exist there, it could be very different from anything we know. And that raises another question. Should we go at all? Interstellar exploration is not just a technological challenge, it's also an ethical one. If we discover life on another planet, do we have the right to interfere with it? Could our presence cause harm to an alien ecosystem? Or worse, could we bring something back that harms us? These are questions humanity has never had to face before. And yet, despite all these challenges, the dream of reaching Alpha Centauri remains alive, because it represents something deeper than just exploration. It represents our desire to go beyond our limits, to reach out into the unknown, to become a truly interstellar species. For now, Alpha Centauri remains out of reach, a distant neighbour shining in the night sky, close enough to inspire us, but far enough to remind us how small we truly are. Perhaps one day, future generations will look up at that same star system and see not a distant dream, but a reachable destination. Until then, Alpha Centauri stands as both a promise and a challenge, the closest star to Earth, and still too far for humans.